Good day, welcome to this lecture video. So today we are going to use one particular inferential statistics. So first, of course, let us pose the problem that we target to answer. And this problem is, let's use our whiteboard. So we will be answering the question, is there a significant difference between the BMI of male and female students or respondents in the general. So we know that this problem is a comparison. And when we are, of course, using the hypothesis testing to solve this, we need first to determine or to state what is the HO of our problem and what is our HA. So step one is to state the null hypothesis and the alternative hypothesis. We will use symbols. So we know that the symbol for sample mean is X with bar. So we can actually state this as mean of sample A or the male is equal to the mean of female BMI. While for alternative, so for alternative, we are of course stating that either one is higher or one is lower. Or using a two-tailed test, this is simply telling that the mean of the average mean of BMI of male is not equal to the average mean of BMI of our female students. Or in other words, we can also state this as there is no significant difference between the average BMI or mean BMI of male and female students. While for alternative, of course, this is just the reverse of our null, which is also stating us that there is a significant difference. So we can just copy this. So for alternative, this is also simply telling that there is. So as mentioned, this is our HA and this is our HO. Okay, so this is the problem that we want to answer. So is there a significant difference between the BMI of male and female students? So we know that, of course, we have several inferential statistics that we can choose from. But of course, in choosing for the particular test that we need to use, we have to consider the objective of the study, what is the nature of the data? Is it normally distributed or not? Is it at least interval or not? So we are, of course, familiar with what we call as parametric and non-parametric test. We know that parametric test is a better test, or actually it's even described as a more powerful test than non-parametric tests. So for us to answer this question, we have to check or to make sure that we satisfy a particular test. So by the way, so what is the what do you call this? What is the possible test that we can use for this particular problem? So step two, let's identify what possible tests are we going to use. So for step two of this, since we know that the problem is a comparison, And we also know that BMI is a numerical. So what we need to do is to check if our data is normally distributed. So if we satisfy this condition, then it means that we can use the t-test for independent samples. While if we fail to satisfy the condition, then we're going to use the non-parametric part or counterpart rather, which is the Mann-Whitney U-test. Okay, so let's check if our data is normally distributed or not. So let's move to our data. So as mentioned, we can only use the test for independent sample if we are sure that we satisfy the condition of t-test for independent samples. So this is our BMI. So the BMI is at least interval. So check, it's a numerical. Now it's a comparison of two, so male and female. So it's possible that we will be using t-test. But let us check if the data is normal. So this is now our concern. So to do that, this is the functions that we can do in SPSS. So click Analyzed, Descriptive Statistics, and Explore. So of course, initially, this is what you will see. So we will transfer BMI in the dependent list. As you can see here, we also identified what is the measure of our data. And then for the factor list, so we will be placing sex in our factor list. So this is where we have to place our grouping variable. Next, of course to click plots and then check normality plots with test. Then click continue and okay. So here we have our result. So this is the result after, of course, doing the process. And we can see here that there are several results it that will be generated. So such as, so we have the descriptives, a test of normality, so even presented stem and leaf plot. So of course, you can go over this, but our main concern is just to look at the value of test of normality. So we have two particular tests of normality presented here. The first one is the Kolmogorov-Smirnov test, and the other one is the Shapiro-Wilk. So what test do we need to report? So we will be reporting Shapiro-Wilk if our, of course, N is less than 50. While if it is 50 and above, we will be using test Kolmogorov-Smirnov. So in our data, it is less than 50. So 14 is, of course, less than 50. 21 is also less than 50. So which means Shapiro-Wilk will be used. So for Shapiro-Wilk, the HO here when we are using test of normality is that there is the data is normally distributed. So we aimed to get P greater than or equal to 0.05 so that we will be accepting HO, which means the data is normally distributed. So looking at the values, so this sig here is actually our P value. So 0.216 and 0.313 are obviously greater than 0.05. Therefore, so what can we tell about our data? Our data is, so the data of male and female respondents with regards to their BMI are normally distributed. So just to check why we are doing this, so this is just a preliminary analysis before we can decide that we will be using parametric test, which is t-test for independent sample. So we are now sure that we will be using t-test for independent sample. Okay, so let's go back to our data. So again, of course, this is our data set. So how will we generate t-test for independent sample? So again, we will be using analyze, compare means because our objective is to compare means, and independent sample t-test. So we will be placing the test variable BMI and the grouping variable 6 here. So to define groups, we have to be aware of the codes that we use or the coding scheme. So we can see here on the side that the numbers that we considered are 1 and 2. So define group. So we have to place 1 and 2. Click continue and okay. So this is now the result of our t-test for independent sample. So let us consider exploring this table. So the first table will show you the descriptive statistics. So it contains the value of the sample size for each of category. So there are 14 males, 21 females, and the value of mean. So we see in this table that we have higher mean for female and lower for male. For the standard deviation, so we can also have an idea of what is the standard deviation of our data because it's also presented. And of course, the standard error mean. On our next table, so we have here the Levene's test for equality of variances and the result of t-test for equality of the means. Before we can identify, you can see here that we actually have two results. Result for equal variances assumed and result for equal variances not assumed. So before we can decide what test or what particular result are we going to report, though it's very obvious that the result here are the same, it's of course very important that we first check another assumptions that we need to consider whenever we are using this test, and that is the Levene's test for equality of variances. Or sometimes, this is also called Levene's test for homogeneity. So it's equality of variances. Looking at the standard deviation, we can of course see that we have different standard deviation, but we cannot conclude that one, since they are different, it already means that they don't have equal variances, or it already means that we have to use equal variances not assumed result. So just like the value of mean here, that we know that the BMI of female is higher than male, we cannot conclude that this is already significantly higher than the other test. Of course, that's because that's actually the reason why we are using t-test for independent samples because that is what we really want to know if the difference is significantly higher or not. Now, the Levene's test result for p-value is this one. So similar on how we identified or how we concluded whether we will be using the first result or the second result. So we considered, of course, using our test, and HO here again means that we have equal variances assumed. So of course, the HA is equal variances not assumed. So if P again is greater than or equal to 0.05, it means that we will be accepting our, so it means that if it is higher, it means that equal variances assumed, or it means that we will be accepting our HO, or I mean for this value now, so p value is 0.008, so which means we are rejecting our HO because it is less than, it's less than 0.05. And if we reject our HO, so it means that equal variances not assumed. So instead of presenting the first result, which is this one, we will be presenting the second result. So where is that result? This result. So it means that T, degree of freedom, we will not be using 33. So we will be using 27.385 is equal to negative 4.775. And P is of course 0.000. And it means that it is significant at 1%. This is significant at 1%. Now let's have more information about the result. So what we have here is that we were able to see that the result that will be reported is the result coming from the equal variances not assumed because our HO is equal variances assumed, and the value is less than 0.05, indicating that we have to reject HO. So let's go back here. Now that we know that this is of course the result, so we are of course sure that this is now the result or the p-value that we have to report, we have to go back again. What is our HO? Our HO in the our problem is there is no significant difference between the BMI of male and BMI, average BMI of female. However, here P is equal to 0.000, which is of course less than 0.01, indicating that we are going to reject HO. So we are rejecting HO if P is, or rather we are accepting HO if P is greater than or equal to 0.05 at 5%, of course. P is greater than or equal to 0.01 if we are of course using the 1% level of significance. So P is equal to 0.000, which is less than 0.01, indicating that we will be rejecting HO. Therefore, there is a significant difference between the mean of the BMI of male and the mean BMI of female students. So it also further means that since we have higher value here, this is significantly higher than, of course, the BMI of the male students. Okay, so this ends the video. Thank you for listening.